In example 1, we want to use the limit definition of the derivative to find the derivative of the function f of x equals 1 over x squared. We're going to start by writing out the definition of the derivative. We have the limit as h goes to 0 of f of x plus h minus f of x all over h. So we start by figuring out what is f of x plus h. Well, f of x plus h says we take the formula for f of x and replace the x with x plus h. So we're going to get the limit as h goes to 0 of 1 over x plus h all squared. F of x is going to be 1 over x squared. And we're going to divide this whole thing by h. Now, this expression is annoying because we have a difference of fractions all over h. So rather than thinking about this thing as being dividing by h, we're going to think about it as multiplying by 1 over h. So we put 1 over h in front in brackets. Then we want to subtract those two fractions. To subtract those two fractions, we put them over a common denominator. The common denominator is x squared times x plus h squared. It's the product of the two denominators. Multiplying the top and bottom of the first one by x squared, we get an x squared on the top. Multiplying the top and bottom of the second by x plus h squared, we get an x plus h squared. There. Now we need to simplify further. To do this, we need to expand that x plus h squared. So we're going to get the limit as h goes to 0. This 1 over h in front is going to stay. And the x squared is going to stay, but when we expand the x plus h squared, we're going to get an x squared plus 2xh plus h squared. That negative sign in front is going to distribute. We get x squared minus 2xh minus h squared. We're going to have this whole thing all over that common denominator. Now we can simplify the top. The x squareds will cancel. We're just left with a negative 2xh minus h squared. Now, to cancel with the 1 over h, we need to factor an h out of the top. So we're going to have 1 over h in front. We're going to pull out an h, and we're going to be left with negative 2x minus h. And here on the bottom, we're still going to have x squared times x plus h all squared. The point of pulling out this h is to cancel it with this h in the 1 over h. The h in the 1 over h, or the h in the bottom of the limit definition of the derivative, we're always going to need to cancel in order to find the derivative. We've now canceled the h, which is great. Once you've canceled the h, you can plug in 0 for h, and you should be able to get an answer. So the top will become minus 2x minus 0. The bottom will become x squared times x plus 0 squared. So the top is really just minus 2x. The bottom is x squared times x squared, which is x to the 4th. Cancel an x from the top and bottom gives you minus 2 over x cubed. So the derivative of f of x equals 1 over x squared is minus 2 over x cubed.